Hi, this is Mr. Anderson, and in this podcast I'm going to talk about matter. What is matter? Matter is anything that has mass and takes up space, and so we'll say that it has a volume. Now, scientists got together and they decided to think about, what was the greatest discovery of the last 100 years? And they eventually came up with this discovery by this scientist named Hubble. And what Hubble discovered is that no matter where he looked in the universe, everything in the universe is redshifted. That means everything is moving away from everything else. And so if we play that backwards through time, what that led us to is this point at which all matter began as a single point. And so that's where we got this idea of a Big Bang, and that there's been this expansion of the universe. But what is that universe made up of? Matter. A lot of it's actually dark matter, but that's a totally different story. This is a cool side note. This is called aerogel, and so this is it's a solid, but it's an incredibly low density solid. And it's actually made by making a gel and then replacing that liquid inside there with a gas. And so here's cool. It's insulating this flower from a Bunsen burner, which I think is pretty amazing. So we'll talk about states of matter in here as well. So what is matter? Matter can be broken down into two things. It can be broken down into what are called pure substances, and then it can be broken down into mixtures. And so everything you think of, from myself to the air that I breathe, is one of these things. And so the first one is going to be a pure substance. And so example, this is helium gas. Helium gas is made up of only one atom, and so we call that an element. Carbon, for example, carbon in a pencil that you might be using, is also an element. It's only made up of one type of atom. As we move up the level in pure substances, we can also have what are called compounds. And if you have something that's made up of, for example, one or more atoms that are put together in a specific ratio, two or more, then we have a compound. And so some things that you're familiar with would be like H2O or water. So the water in this droplet right here is made up of 2 hydrogen atoms and 1 oxygen. Or the glucose that's inside this plant right here is actually a compound as well. And so pure substances are simply elements and compounds, but they have to be pretty pure, and that's where they get their name. Next we have what are called mixtures. An example of a mixture, one of my favorite mixtures, would be soda. This is actually Mountain Dew. Inside here, if we could look inside the can, that would be a homogeneous mixture. Homogeneous mixture means that you can't tell apart the different parts inside it. And so if you were to look inside Mountain Dew, there's going to be water, but there's also going to be carbon dioxide, and there's also going to be sugar, and there's also going to be caffeine, and there's going to be yellow dye, number 5, and all those things are mixed together, but you can't tell the different parts. So we call that a homogeneous mixture. Now, most everything that you're used to dealing with in life, like me or the computer sitting in front of you or anything, is not going to be that. It's actually going to be a heterogeneous mixture. Heterogeneous mixture is when you can see the different parts. And so this is blood. And so we might think blood looks like a homogeneous mixture, but when you get down to the level of blood, we can see red blood cells, white blood cells. We could even get down to the level of platelets if we looked at it. And so that's a heterogeneous mixture. So that's how we classify everything. Now, this is a great diagram because it shows you in the universe, this shows you the atomic number. So we're going all the way from the first, hydrogen, all the way up here to uranium on the far end. This is how much they naturally exist in the universe. And what you find is that we have a lot of hydrogen and helium. We don't have so much beryllium. And then we have these points that kind of level up as we go through the atomic number. Now, this is a log scale. That means we have a whole bunch of hydrogen and helium. And you might be thinking, I wonder why that is. Well, the sun gets its energy from hydrogen fusing into something called helium, and that gives off a huge amount of energy. If you've heard of this before, E equals mc squared. This is Einstein's Einstein's equation. Relates energy and mass. And the cool thing about it is when we convert hydrogen to helium, we actually lose a little bit of mass. But where does that mass go? That mass is converted to energy. And it's the energy that's giving me the sun in this room right now. Okay, so the idea of atoms and molecules came from the Greeks. And there was this guy named Democritus. And Democritus said that we could break down all matter